Hello, everyone, and thank you so much for joining us today for what promises to be a great discussion on data observability, data trustworthiness, and data quality. I'm joined today by Seth Rao and Ibby Rahmani, FirstEigen and Alation. I'm Joe Hilleary. I'll be helping to moderate this session. I'm a research analyst with Eckerson Group. For those of y'all that aren't familiar with us, Eckerson Group is an industry analytics company and research firm. We also do consulting. You can see here some of our recent clients. We specialize in data and analytics. And I'm going to go ahead and let my guests introduce themselves. So first is Seth Rao of FirstEigen.
I'm Seth Rao from FirstEigen, and I'm the CEO and co-founder. We specialize in autonomous data trustability validation software. And
Ibby, you're joining us as well. So glad to have you here.
Thank you for having me here. Hi, everyone. This is Ibby Rahmani. I'm the Director of Product Marketing here at Alation. Alation, as you know, is the leading data catalog provider.
Terrific. And without further ado, we will take care of a couple last housekeeping things and jump right into it. So we'll be saving some time at the end for questions. So if you've got some, feel free to put them in the Q&A box within the webinar, and we'll try to get to them at the end. Yeah, focus those on the Q&A. Sometimes you have them come in the chat. That's okay. We'll try to get them over, but there is a Q&A function. That's the one to use. And now to the topic of today. We're here to talk about observability. Now, this is maybe a term you've seen a lot in the last couple of years as folks have started to use this terminology in a variety of ways. It's kind of become difficult to figure out, okay, what is observability? How is it different from data monitoring? How is it different from data quality? What all these things mean? So I'm going to try to lay some good foundational groundwork around what observability is, the different kinds of observability, and then Seth and Ibby are going to take a look at how their different tools address different aspects of the observability workflow and the ways they can help organizations create better insight into their data pipelines and the data they're actually working with. So observability. Here at Eckerson Group, we like to talk about 5 different kinds of observability that we think kind of break down and make tangible things that often fall under that observability umbrella. So at its core, observability is kind of next generation monitoring, right? So rather than simply monitoring, there's a level of correlation and optimization that goes into it. So it's real-time embedded insights into data, but that data could be different things. So at a really high level, you might have business observability, which comes out of the business monitoring space, looking at really high level trends, business metrics, sort of how is my business functioning, and sort of observing at that really high level of abstraction. You have operational observability, which is really looking at your resources, your application performance, and the way your infrastructure is operating. You have data pipeline observability, which is one of the 2 kinds we're really going to focus in on today, which is looking at your performance in relation specifically to data pipelines, right? How are flow rates? How is the infrastructure that supports that? What's the utilization? What's the availability, uptime, downtime, specifically for those data pipelines? You have model observability, which is a piece of the machine learning life cycle, looking at how models change over time, improving their performance and accuracy. And then finally, at sort of the most granular level, we talk about data quality observability. And so this is, rather than looking at the infrastructure, the way that middle layer is, actually the data itself, right? What's happening on a really granular level regarding the accuracy, completeness, consistency, and timeliness of that data. So as I referenced, this is a conversation really focused around data, right? We're not worried about business observability or machine learning observability. We're focused today on what we would categorize as data quality and data pipeline observability. So let's sort of disentangle, because a lot of times people just say data observability, right? That's a pretty common term. But sometimes they mean it to say one, and sometimes they mean it to say the other, and sometimes it's sort of used to talk about a combination of both. So to make this a little bit more concrete, let's talk about the pieces that go into each one. When I talk about data pipeline observability, that's an infrastructure question, right? That's where I want to look at my containers, my storage. I want to know sort of what are the resources that are being used when I run a data pipeline? Where is my budget going for my AWS account? Where am I having breakdowns in my data flow? Which applications aren't communicating with each other? I want insight into that flow of data from a source system into my data lake, into my data warehouse, into my end user applications, right? I want to know what's happening to the data as it moves along. And that's really sort of a higher level picture of data flow. Data quality observability is focused on the data itself, what's actually inside those files. So that's where we get into things like close level observations about the completeness of data, right? How many nulls are there? Or sort of intercolumnar relationships. How is my data changing as it moves through that pipeline? Not just, is it moving? And it also feeds into sort of capabilities around data lineage and things that might pop up in a data catalog, right? So if I'm going to look at a data asset in a data catalog, I want to know what's in that data and where it came from. And that's the kind of observations that data quality observability is providing for me. So historically, when we talk about this kind of data observability, a lot of times tools focus on the data warehouse as sort of the point of observation. And this is something, as we start to talk about beyond observability, I think is really important to consider, which is where are we actually looking at these different aspects, right? It's great to say, okay, I want to know what my data looks like. I want to make sure I'm checking for quality in an automated fashion. I want to make sure that I'm sort of finding correlations between historical data and what's coming through today. But that has limited application. It can tell you sort of what's present in front of you, but it can't tell you where things happen. So particularly with data quality observability, this becomes really important. I may be able to identify that there are errors in my data, but unless I'm looking at multiple points in a data pipeline, I don't know where those entered my data set. And so this is where data quality observability and data pipeline observability really need to work together, right? We can talk about them as different sets of functions, but at the end of the day, they work in tandem. So if this is, typical data pipeline in a modern environment, obviously simplified, but we can look at, I've got some sort of source system that's generating that data. It's moving through a pipeline into a cloud data lake where, huge volumes of data are coming in. Maybe there's some operational applications that are coming off of that. And then I'm moving some of that into a data warehouse, maybe Snowflake, maybe other environments within the cloud that my analytics teams are going to query that data from for various business intelligence use cases. This area is where I've typically seen data quality observability vendors focusing, right? It's a layer that sits on top of the cloud data warehouse. My data is automatically being scanned. I'm sort of creating correlations within that data, identifying lots of really interesting statistics, and then providing those to analysts when they come in to view them so they can have a better understanding of where their data is at, if this data is usable, what's gone wrong. What it should really look like is points of observability in between each of these steps. And what that comes back to is the ability to trace back. If something has gone wrong, how do I know where it happened? How do I fix it, right? Or better yet, can I catch it before it gets to a business user? And these are things you can't do. If you're just observing at a single point, all you know is that one slice. You can't see how it's transformed within the pipeline, only how it compares to previous versions of that same data asset. So when we talk about beyond observability, part of that is putting those points of observation in between each transition. And particularly when you're dealing with lots of applications, that becomes super important because one of the places where errors are most likely to enter a data set is in that handoff, right? When I'm integrating between a source system and a cloud data lake, particularly in the cloud, I don't necessarily have control over that infrastructure or that environment. So if a service is down for a few minutes and it gets off sync, all of a sudden I've got a lot of errors in my data that came in earlier in my pipeline. And if it just keeps chugging along until it hits the data warehouse, I don't know where it went wrong, where to roll back to, and how I can fix that. But adding those additional observation points helps you to do so. So why are we doing all this? Why are we promoting data observability in the first place? Why are we sort of going to this added step of creating trace back capabilities? Really what it comes down to in a lot of cases is trust. Trust is rather intangible, but is crucially important for a data team. Because at the end of the day, data by itself doesn't do a whole lot. Data becomes valuable when it helps inform a decision or drives some sort of action, right? And so that could be an automated action, right? If I've got an application that's using data to provide a service within a consumer-facing application, that data is providing a service directly. It also provides value on a business operational perspective when an executive or someone in a place to make decisions about the business makes a better decision because they have the data and the evidence to choose correctly. you'll notice both of these require the data to actually be used. And particularly in the latter case, people don't use data unless they trust it. We see this over and over again when we talk with business users. The only time a business user is going to rely on their data and truly make data-driven decisions is if they think the data they're getting is decent. If there's really poor quality data coming up in front of a business user over and over again, if their dashboards are constantly down or constantly have errors, they're just not going to trust it, right? They don't want to make flawed decisions based on flawed data. But with observability, not only can you start to create accountability by saying, okay, well, yeah, there's a problem, but we know where it happened and we know how to fix it, and you have the traceback to go and rectify those issues, you can actually start to preclude some of those issues to begin with. If you've got that sort of in-pipeline observability capability, you're sort of seeing where things go wrong in real time, you're able to prevent it from getting to a stage where it starts to impact business users' trust of data. If you're catching it before it hits the data warehouse, if you're catching it while it's still in the pipeline, leaving the source system, and you're able to make an intervention there, by the time it gets in front of a business user, it's already been vetted and validated. So that earlier interception of errors allows business users to have greater confidence in their data, and therefore it makes them more likely to use it. So great, you've got business users getting higher quality data in front of them in environments where they're making decisions. But why is that important? So like I said, if you're relying on the data, you're making more data-driven decisions, and you've got less energy being devoted to this back and forth, right? When a business user says, oh, there's something wrong with my data, this doesn't look right, that kicks off a whole workflow that takes time away from the business user doing their tasks that they're supposed to be using that data to do. And it takes time away from IT, who can't build out new capabilities and instead is forced to go back and forth and figure out what went wrong, what happened. But with the sort of trace back and this early intervention, there's less time devoted to that back and forth. And ultimately, if your data is of good quality and you're starting to make more data-driven decisions, history has shown us that leads to better business outcomes. And so we can sort of quantify that in the reverse, right? What happens if we don't have trust in data? What happens if we have poor quality data? Well, we waste a lot of time and resources, right? We're spending billions of dollars every year across industries on data infrastructure, on analytics solutions. And if we're not using the data, that was all just a waste, right? If we're using the data, but the data is not right, if it doesn't even get caught by the business user, that's going to lead to poor decisions, right? That's worse than making a decision with no data at all, because now you're making it based on incorrect information, incorrect understandings of the situation. And there's some interesting numbers out there. So we talk about the cost of poor quality data as about 3.1 trillion in the US market alone. Now, this is a number from IBM, from some research they did a few years ago, but I think that sort of signals the magnitude of loss, right? Wasted time and resources sounds like something fairly negligible, right? It's a little squishy, but that wasted time and resources really adds up. And so, Gartner talks about 9.7 million as an average cost per company across industries. Again, it's just based on data that can't be trusted, so it's not being used, time wasted dealing with poor quality data. And so the more we can get in front of it, the more we can sort of alleviate that concern, the more we're truly saving for our businesses. So hopefully this little summary has given you a good sense of sort of what is observability? What are those different kinds of observability? And why it's important that we have that. Also, where are the shortcomings of observability, right? If we're only looking at one point in the platform, then we're only getting one slice of the information that we could. And so sort of moving beyond that singular point of view to multiple points of observation becomes really important and powerful. And so I'm going to go ahead and hand off to Seth, who's going to talk about the platform that he's built with FirstEigen that sort of looks to do a lot of this and implement some of the things we've talked about. Seth, I'll let you take it from here.
Thank you, Joe. Let me share my screen. All right. So I'm just going to pick up where Joe left off here. We're going to cover these 5 topics today in my presentation. And the main emphasis is going to be in the last 3. There's a pretty significant gap between what observability can deliver and what is actually needed in the marketplace. So data comes in. I can guarantee you there are always a few errors. It could be in parts per million. Usually goes to a data lake which tends to accumulate these errors, and then to a warehouse, which persists those errors. It's used in different models, which are used for predictive analytics or reporting, and then you end up making bad decisions. Now, the traditional way to approach this is have a data quality team that answers the basic question, does the data meet a static set of standards? And of late, the last couple of years, observability is a new term that has come up, and it tries to answer the question mainly from a data engineer's point of view. Should the data pipeline be stopped so that the bad data does not go to the end? And as Joe has pointed out in his part, doing it on the warehouse may already be a little late. It's best to do observability slightly ahead and also at multiple points down the line. So in spite of the observability tools and the data quality tools, a lot of investment going in, why do we still get a lot of errors? About 40% of the initiatives fail. There's a huge drop in productivity as well. So why is that? Now, let's take both of these and look at it as to what exactly do these provide. Observability, it's mainly designed for upstream data engineers. And it tries to address these 5 questions. The first 3 are the most important ones that it tries to answer. Now, the problem with every observability tool that's out in the market is it is very restrictive. It has to be done file by file, and it's pretty laborious to create and invoke data validations. Now, on the other end of the spectrum, you have data quality. Now, data quality is designed for downstream data quality team, and it answers the question, does my data meet a set of static standards? And there are 6 different dimensions in which it looks and validates those data. Now, the challenge with that is the users have to sift through mountains and mountains of data to find what are the rules of trustability that need to be put in. And hence that makes it very expensive and also very slow. And once those rules are discovered, to put it in, there is a heavy dependence on the IT team. Now, the problem with data quality is it is pretty static. Rules that were determined a long time ago continue to be used forever and ever. Even your data has evolved, it has changed, the ecosystem has changed. Those rules become very static. Why? Because you have tens, if not hundreds of thousands of rules. It's not scalable, and it's often error prone. Because of these group of tools cropped up to meet some of these demands. Now, think of it as an analogy. We started off with data quality teams, equivalent to having these clunky heart monitoring devices. Then people felt there was a need for something a little bit more smaller, addresses a small part of the problem, doesn't have to solve the entire problem, but a small part, which is observability, addresses about 20% of the issues. Now, the problem is each of them solves a small part, and the end result is there is lack of trust in the data throughout the pipeline. There is not enough visibility. So what is needed is something that is easy to strap on, something you're not spending too much time, but it'll do more than just data quality, more than just observability, but it'll give you a high-level information, which is very rigorous, and a lot more information that you can act on to control your pipeline. So what we did was talking to different customers who were experiencing this pain. We designed Databox. Databox answers the question, is the data trustable? Is it usable, publishable, anywhere along the pipeline? Databox creates a fingerprint of the data. It self-learns from the data autonomously as the data comes in. And as the data is dynamic, the fingerprints are also dynamic and the fingerprint evolves. It is able to detect known errors, things that you know will go wrong. It monitors those. It also looks for unknown errors. And in the end, it gives you an objective data trust score. It's no longer a popularity contest whether somebody A, B, or C likes a certain data and says it can be used by others. Databox eliminates the subjectivity and gives you an objective data trust score. So there are multiple challenges that the users face, and we have seen the need for more trustable data literally exponentially grow in the last few years. And the traditional approaches to validating the data are extremely costly. So our approach is a completely new approach. You don't assess the trustability of data by writing rules and saying if the data looks like this, then it is trustable. If the data looks like that, it is not trustable, and so on. But by automatically sensing the changes in the fingerprint of the data using machine learning. Every data set has a unique fingerprint. And we have had conversations with multiple customers who say, you know what, my data is so unique, there's no way you can fingerprint it. The answer is yes, you can. You just have to go down to a very detailed level and look at small microsegments of data, and you will be able to find fingerprints that can be used to validate the future and incoming data. So what is this thing called fingerprint? So we have machine learning algorithms that autonomously track and create multiple fingerprints that software automatically recognizes the microsegments within your data. And for each of those microsegments, it creates fingerprints. And it also creates multivariable spatial fingerprints, microsegment fingerprints, hierarchical fingerprints, and multi-time cycle cyclicality fingerprints. So if you combine all of this into one big fingerprint, that is a lot of information on the data to be able to track and say, do I trust this data? A change in the fingerprint could indicate an evolution of data or an error in your data, and hence the trustability in data is low. So with this concept, what we also did was we expanded the point of applicability of trust. Typically, data quality people are in the end, the point of consumption. And the data observability people are more in the beginning, upstream. But a data trust score has to be tracked all the way from the beginning through the pipeline and through the point of consumption. And Databox is designed to do exactly that. And even better, the holy grail is when the data engineering team can create data trust sensors, embed them along the pipeline of the data, and those sensors communicate the results to the business user or a data steward, and they can constantly be aware of the trustability of data every point, and they can then tweak and communicate back to the sensor whether the pipeline should be tweaked, should be stopped, or is it okay to go. So the business user gets complete control over the pipeline because they get a sense of the trustability. Now, what I'm going to do is quickly switch into a few minutes of demo of what exactly Databox does and how easy it is to implement it. All right. So it's a web-based UI. Through the Databox, the data engineering team can essentially give the connectivity credentials. Very simple. And note what I am not telling the software. I'm not telling the software anything about the data, whether it's a financial services data, it's a healthcare data, insurance data, IoT data, or anything. All I'm doing is pointing Databox to the source of the data, and I say health check. And as soon as I hit health check, three things happen. The software completely profiles the data, creates a deep fingerprint of the data at a microsegment level. Then it uses that fingerprint and creates rules and validation checks for that data. And thirdly, it goes and actually validates the data. So I'm not going to hit the health check, but as soon as I hit it, we can go and see the results of what Databox provides. So with just 3 to 4 clicks and no information on the data, the software figures out what is the data trust score at a project level or a schema level. So this can be thousands of files or thousands of tables on your Snowflake. And you can get more details on the different types of tables that you may have. And you could go down to another screen and look at the data trust score for individual tables. You can double click on any of these and you could get the data trust score and the trust score of the different dimensions of data quality for an individual table. So you could double click on any of these, and you could further drill down to the bare bones level of where exactly is the trust in the data lacking. So you could go up here, you could look at essential results, advanced results, and you could see further dimensions of data quality, which contribute to the trust in your data. So for example, here in the regex pattern, software, as a part of creating the fingerprint, automatically recognized that certain columns in your data have fixed patterns. And those patterns look like these. In this particular run, 2 records failed to meet this pattern. Zip code is 5 digits, and 2 records failed to meet that pattern. So the power of the fingerprint is the user does not have to know anything about the data set a priori. The user does not have to tell Databox what to look for, not to look for. The software, with its machine learning algorithms, automatically discovers what are the most relevant columns and what is the fingerprint that column is creating at a microsegment level. Now let's quickly jump to the duplicate check. This is something very powerful, and commonly it's a big problem because lots of different platforms don't enforce duplicate checks. So here, the software does something very interesting. Machine learning algorithms automatically figures out what are the composite primary keys. Again, the benefit is the user does not need to know anything about a table or a file. The software will automatically figure out that this particular data set had a composite primary key that was made up of these 5 different columns. And there was a single duplicate based on this primary key on this particular one. And a different set of primary keys had another duplicate, and so on. So this is a very powerful concept. The software can, along with creating the fingerprint, also has enough intelligence to understand what kind of checks to do on what kind of columns, which are contextually relevant and most important. So for example, it will not do null checks on every column. It will do on those which are contextually relevant. And if you go to look at some more advanced results, the software, as a part of the fingerprint creation, it checks a whole bunch of advanced data-related issues. So in the record count anomaly, the software automatically recognizes that the data has multiple microsegments, and each of these microsegments behave differently. So we have worked with some pharma companies where a single table has had as many as 12,000 microsegments. So for that single table, the software creates more than 12,000 fingerprints for each of those microsegments, encompassing different pieces of information. So here, for example, in the record anomaly, the software is recognizing that these are the different microsegments. This is a very simple data. So just a handful of microsegments, and each of these microsegments has a different behavior of the total number of records. So when there's a change, it could imply there is a change in the evolution of data, or there could be a lack of trust in the data. Okay. Now, that's a very quick and high-level overview of Databox and how, using machine learning, you could very easily figure out if the data is trustable or not. Now, we have worked with multiple customers, and what we have seen is when employing the concept of trustability throughout a pipeline, users end up reducing errors by over 70%. They are a lot more productive, and the cost reduces by over 50%. And these 3 benefits are mainly driven by the fact that we use machine learning to do a big chunk of the load lifting. Your subject matter experts are now more free to focus on the more important aspects. Databox will do the essentials of data trust. Powered by machine learning, we are able to reduce the time to onboard new data sets for trustability by over 90%. And we have designed it to be native for cloud and lake applications. What we're going to do is today we are announcing a free community version of the Trustability module, which will be available to any user. This is on a wait list, which will be shipping on August 31st. And if you're interested, please note this email, and it's also appearing in the bottom of every slide. Shoot an email to us, and we'll put you on the wait list for a free community version. As you saw in the demo, there will be no coding. You can simply point to a lake or a data warehouse, and you'll be able to get the information that we saw here, data profile. You'll get a data trust score and very detailed information. Data trust score at a schema level, or for every table, or for an individual table. And also, you would be able to have self-service capabilities. What I didn't cover was you have the ability to teach the software what is acceptable and what is not by these thumbs up and thumbs down. So you're not having to write rules. The business user can just give a feedback from this interface to the software, and it'll evolve and capture your needs, and the fingerprint will change automatically. So with that, we'll now hand it over to Ibby of Alation.
Thank you, Seth. Just bringing on my presentation over here. All right, we saw a little bit about data observability from both Joe, from a concept point of view, and how Seth talked about how FirstEigen provides value to the users over there. Now let's talk about Alation and what Alation provides to our users. For the agenda from my side of the section is we'll talk about why you need a catalog, why Alation, and our data quality initiative, open data quality initiative, and I'll end up with a case study. So let's get into it and understand, why do you need a data catalog? Well, there are a lot of catalogs out there, and there are some bare minimums that a data catalog should have. For starters, a data catalog is a place where you have one platform where all the information metadata is stored and shared and collaborated across the organization. When users try to find and understand data, this is where they come. They come to the data catalog, they will do a search and discover. And through the search and discovery, they use normal human/natural language to find the data that they are interested in. Once they find the data, they want to also make sure that they trust the data. We talked a lot about the trust in data. So Alation, by virtue of how it is, it provides some governance guidance to our users. So as users are using the data, they'll find warnings, deprecations, endorsement information regarding the data as they're using the data. And from a data steward point of view, they want to curate it so that they can provide governance. And when the governance comes in place, they want to curate it at scale. So we provide autonomous functionality to our data stewards as well. Finally, it's collaboration. Why is collaboration important when you think about a data catalog? The reason it is important is because as you collaborate, you bring in more information about that data set that you're working on so that users can use and reuse the work that has already been done. We know that 70% of time, people are trying to find, understand, and use the data. And this is where the data catalog helps. Furthermore, it has a broad range of information assets, whether it's virtualization, conversations, reports, and articles about the data. Included in some of these data catalogs are also things like business glossary, which is like one of the basic things that's there. And then there's lineage information, catalog pages, and search, making life easy for the business users. So key thing to keep in mind is when people were working with data back in the time, it was mostly by the data engineers. Now with Alation and tools like data catalog, you can involve the business users as well. That is, help them understand the core questions, where they can find information and they can also understand, can they use that information? Because because they need to know if they have the right credentials to use the information. And should it be used? Is the data of good quality? And if it should be used, how can it be used? So all that really helps them make right business decisions. Now let's talk about the Alation data catalog. We just talked about the data catalog, but what is Alation data catalog? For that, we need to understand that Alation basically started the machine learning data catalog trend. If you look at Gartner's and the Forresters and the IDCs of the world, all the analysts, we have been winning these awards year over year for the data catalog, and we have been chosen the leaders in the space. So when I talk about Alation Data Catalog as a platform, what does that really mean? What it really means is it's a platform for data intelligence solutions. When you're thinking about digital transformation, data governance, analyst productivity, cloud transformation, risk and compliance, Alation leads in all of these business initiatives. We know that when it comes to data governance, after 18 months, only 30% of consumers have data governance in place. It's really hard to scale data governance. And the reason is traditionally governance has been more about restricting, trying to create guardrails. Whereas Alation brings in what is called as an active data governance, where we engage the users, where we know who are the critical users, so we empower them to also take care of governance. And through that, most of our customers are able to scale governance in place and add automation to that as well. And obviously, I'll talk about the data quality initiative, which really helps the data governance further. When we think about analyst productivity, it's not just finding the data. It's not just understanding the data. It's about, can I make the right decisions to make the right business impact with the information that I have? That's analyst productivity comes in, because we not only help you search or find data, we have a tool that is an IDE tool, that Compose, where people, as they write the queries, it provides guidance so that business users can also use that tool and find information quickly. They don't have to wait days or weeks to find that information. From a cloud transformation point of view, obviously, Alation does not migrate data into the cloud. However, we provide the intelligence for the cloud transformation. What kind of intelligence? Again, according to Gartner research, people at a given time are only using 10% of the data. So when you think about cloud transformation, which can take anywhere from 3 months to 9 months to do a transformation, to plan and do a transformation, it will be good for those users to understand what is the critical information they have, what information they're using. And this is where Alation comes in, because we provide guidance into that critical information, into what is the top 10% of data that you're using and that you will be leveraging, and hence you want to move those data first. Finally, privacy, risk, and compliance. We all know about GDPR, CCPA, ability to share information freely can be restricted, but how do you do so where you can share information between departments, but not share the private information? So we have ways to tag that as well, so that, for example, if marketing has information about a client's address and that information needs to be used by sales, we can make sure that the data set is shared, but not that private information about that client, like their address. So as a data intelligence platform, we help you with all of these business initiatives. So let's talk about the data quality initiative that we just launched. About a couple of months ago, we launched this data quality initiative. And what was this initiative about? When we looked into Alation, we recognize a lot of our customers are talking about data quality, and data quality is a hot topic. That said, we also recognize there are companies like FirstEigen that provides really good quality solution, which are much advanced than what Alation is providing right now. So what we did is we opened our API so our customers can use those solutions and take leverage of the best solutions that's available to them. And they can all surface that warnings from those solutions into the catalog. So as they're going through their workflow, they are not interrupted. They don't have to go through multiple tools. They can go into the catalog, do the search they want, and right there, they'll get information about how they're gonna use the data, if they can use the data, the things that we already talked that the catalog should do. Do they have the right credentials to use the data? Or is the data of good quality? Obviously, Alation as a company has been focused on creating openness towards its platform, not just from the data quality initiative that we launched. We have APIs, we have connectors Today we support about 80 plus connectors for our customers, and that ranges from on-prem, legacy, private, public, cloud, all kind of different data sources, BI, data warehouse, so that you have everything connected to Alation and have a visibility, end-to-end visibility into your platform, and marry that with a data quality solution like FirstEigen. You get the whole visibility into your quality end-to-end through your life cycle or workflow, and make the right business decisions. The final thing for us was we didn't want to lock in our customers by providing our own solution where we just have a solution. We are enabling our customers to have solutions from other vendors as well. So this really adds to the value that we have, that because our value is to serve our customers, not just to serve Alation. If you have used Alation in the past, you know Alation by default has some data quality capabilities within the data quality. Whether it's using data quality within Alation for finding stats, like you can do basic profiling where you can have min, max, nulls, or you can have lineage information. Alation captures all that and provides all the metadata information for the lineage. Obviously, from a governance point of view, I talked about providing workflow and making it autonomous for our users as well. Now, through tools like FirstEigen, what we are able to do is we're going to provide matrix, rules, notifications that will be surfaced from those tools, including Trustability, which Seth just talked about, right into the catalog, making it really easy experience for our consumers. This makes it a one-stop shop for our consumers, so they can get all that information right into Alation, so that they can understand the good quality data right there. So how do we do that? We open up our API. FirstEigen went and did the integration with the catalog. And now all the data quality information is surfaced right into FirstEigen. The benefit is to the customer is you don't have to do that integration work. The integration work is done. And if you look at the Alation tools, what we did is we created a new tab called the Data Quality tab. And through the Data Quality tab, all the rules, the status, the description is surfaced right into into Alation. And through that, you can make the right decisions. So for example, if you're looking into a retail customer who does an update and the update is missing, let's say, some time information, it's fine. We can call it a warning. So FirstEigen can set that information as, hey, that's a warning. We see some of that information missing. You can still use this data set. However, if 70% of the data set is missing time information, then FirstEigen can set up a rule where it can say, okay, now this is supposed to be deprecated, and that data set will be deprecated. So that means you are not going to use it. And obviously, if the data is good, we'll see endorsements. So you will have endorsements on the data, making it really easy for you to make that choice and use the data right off the bat. Now, looking at our customers, this is American insurance company. They needed governance with compliance. And obviously, they tried to lead the IT-led governance, which failed. Like I said earlier, that within 18 months, only 30% of companies are able to scale governance. And the reason being is it's all restrictive. However, with Alation, what they have is an active governance where people are empowered to provide rules and work with data stewards and provide feedback back and forth, where the governance is more of a collaborative way of scaling. So through this, what has happened in this example was they were able to have a business-led governance initiative where people were having self-service. One of the things that people have is they want to have self-service and then they want to have governance. And it's like a tug of war, because if you enforce governance, you cannot have self-service. If you have self-service, you might not have governance. The ideal solution is you have both. And that's what these guys were able to do. That is American Family. So the data quality solution was directly incorporated into the Analyst workflow. Remember, I talked about the workflow. It's really critical. It was incorporated right there. Obviously, as you can see, you get all the benefits from the catalog where they were able to reduce it from weeks to hours when they were able to get the complete glossary. The time savings for the data scientist was also decreased. And what was the reason? The reason was we talked about business glossary. We talked about Alation having an open, so we can also send inbox into the tracks on how the governance is changed and how people need to enforce that. I talked about Compose, and Trust Check is where you get the warnings, the deprecations. So through Compose and Trust Check within Alation, they're getting all the rules and information, and connecting to a powerful tool like FirstEigen, they can have much better information than they used to, and conversations, which is part of collaboration. So all that said, it's been an exciting day for us to share this valuable information to you. So what is next? You can see Alation in action. We have demos for both Alation and FirstEigen Databox. So you can go on the website and see the demo here. I'll leave it over here if you want to do a screenshot of this so that you can ensure that you have the web page available to you. Obviously, Alation has a podcast. You can listen to our podcasts done by our CEO, where we have different data leaders come and talk to him. And there's a lot of interesting learning over there. And FirstEigen has this great blog about how you can scale data quality operations with AI and machine learning. Remember, if there's one thing you want to take away from this, is not just data quality or data observability, but also trustability and ability to scale. And on the right, you have the connections. So with that, let me give it to Joe for Q&A.
Terrific. Thank you so much. Those are two great presentations, and I know a lot of people have had questions coming in this whole time. So we'll try to get to as many as we can in the next 10 minutes or so. All right, first question we've got. Does data quality observability mean capturing observations about pipeline processes or capturing observations from the data pipelines processed? That's a great question. So this kind of gets back to the difference between data pipeline observability and data quality observability from the beginning of my presentation. So the first one of those, capturing observations about pipeline processes, textbook data pipeline observability. That's what that is. It's looking at how are these processes functioning, how are the pipelines performing. Data quality observability is focused, instead of on the infrastructure through which the data is moving, it's focused on the data itself. And that's, here's what this table looked like, here's what this row and column looked like at this point in the pipeline. And now I'm looking at it again and seeing if it's changed, but it's really looking at granular level changes in the data. That's what you're observing with data quality observability. Next question, I think this one's probably directed to you, Seth. Will Databox be required to be hooked at each point of the data pipeline, or will it automatically traverse through the data pipeline to address data quality observability?
So the user would need to point Databox to wherever they would like to establish the trustability of data. Databox could go through and do it at all points, but what we see is that user often says, I don't want to do it at 100 different points. I just want to do it at a few of the points which I think are critical, few points along the line. So user points it to wherever they want to understand the trustability of data.
And then that's kind of what you were talking about, Seth, with the different trustability sensors kind of embedded. Those are the points that you're choosing.
Yes, exactly.
Which maps to that idea of the different observability points that I was talking about as well. That's sort of the concrete, where are you looking in between each of these systems? All right, next question. What if there's an error that requires a pipeline to be paused? How would stewards intervene using these sorts of tools? So, okay, we've identified that there's an error. We got to stop the pipeline. What's the impact on a tool like Databox?
I can take a quick answer, and Ibby has something to add to that as well. So there are two ways to do this. If an error has been detected with Databox, you could then pause the next ETL job. Databox also connects automatically with the data catalog and populates the data catalog with all the relevant information. So for example, with Alation's Open DQ initiative, all the information go into Alation catalog. And from within the catalog, also, you may be able to control your data pipeline, but you could definitely do it from Databox by itself.
Yeah, just to add to that is right. Thank you, Seth. This open new data quality initiative, what we did is we created this special tab within Alation. By default, we had something called a trust check within Alation. So what the trust check did was gave you, think of it as a traffic light, red, amber, and green. That is, whether it's endorsed a certain data set is endorsed, or there's a warning, or there's a deprecation. So as Databox surfaces that information into Alation, we are able to provide that guidance right into Alation, into the user's workflow. Basically, when they're searching for data and there's a problem, they can see that. Not only that, there's also the intelligence on impact. We have lineage, and we can also provide the impact analysis if there's something in the back end, in the upstream that needs to be taken care of, where it needs to be taken care of. So we can also provide that kind of information back to the users.
Terrific. That's great. I've got a few more, so we'll try to get to as many as we can. How do we programmatically implement Databox on various data sources? For example, CSV files being ingested into data lake and data warehouse.
Great question. Databox is built to validate lakes, warehouses, and pipelines. So all you have to do is point Databox to your Azure Data Lake or AWS S3 or GCP, and it'll automatically scan and it'll validate your data lakes for every table that's out there. So it's very easy, number one. And once it is set up, our customers often, for example, in S3, often have Databox sleeping in the backend. And as soon as a new data comes into data lake, the Lambda function wakes up Databox, it validates the data, and it goes back to sleep. So you're not consuming resources when you're not validating. And at the same time, within a minute or two, as soon as your data comes into your data lake, it has been validated for its trustworthiness, accuracy, and reliability.
All right, so our next one concerns a scenario in which different data silos have very different data quality profiles, such as you're integrating a data warehouse following a lot of business growth or M&A. So the example it's given is, what do you do if you have one silo where there's good postal mail but bad email, and a second silo where there's good postal and good email? How does Databox deal with siloed data that might have very different profiles?
So what Databox is really good at doing is validating the data and comparing data. In this case, it's a data matching module of Databox, and to tell you there are errors. What Databox is used most often is in operational and transactional data. So it's designed not to change or edit the actual data set itself. So if you have A correct here and B correct here, and I think the questioner wants to know, can I create a new table where I use the A and B from these two and have a better table where both of them are correct? Databox will point out the errors. Externally, you'll have to see what those errors are and do a join and create a new table. Databox will not do that for you automatically.
There you go. And then next question. Once you plug in data, and I think this is building off of the question we answered before, once you plug in Databox wherever it's required, how do you monitor the stats? Is there a consolidated view or a resource monitor? If I've got all these different observation points, is there somewhere I can see all of that information together, or am I viewing those each in isolation?
Yes, absolutely. So there are two ways to look at those. The first one is within Databox. You can look observations at an aggregated schema level. You could go down to a schema, and that schema might have thousands of tables. You could look at a table level as well. And for example, some of our banking customers, they have different groups that use Databox. You have the credit card group, you have the AML, anti-money laundering group, and you have the customer success group, and so on. Now, all of these groups have their own areas where they store their data, and they get access to just the data that they can see and Databox and the results. And so they get an aggregated view and a detailed view for just their area. So single place. And also, because we can connect back to a data catalog, you could have the same view in Alation as well, where you will be able to see a consolidated view of schemas, tables, and even the individual tables as well.
All right.
And there's one more question. Let me just clarify that was asked previously on programmatic. How do you do it programmatically? Databox has direct integrations, for example, with Glue. So if you have a Glue pipeline on AWS and you would like to validate the Glue pipeline, it can be done directly by API integration. Databox Python library also gives you a programmatic access. So Databox is designed to automate your whole process, make it programmatic so you don't have to do it on an ad hoc basis. The fingerprints automatically evolve. It automatically detects when data comes in. It automatically validates it, and it'll send you alerts automatically as well. So minimum human touch. Everything can be programmatic in Databox.
I think that's about all we've got time for. So thank you all once again for joining us today. Thank you for your engagement and your great questions. Hopefully you learned something, and feel free to be in touch. You've got the contact information for Seth and Ibby if you've got additional questions percolate over the next few days. Have a great afternoon or morning or wherever it is, wherever you are. Take care. Bye.